Hi everyone, and welcome to our video on weak acids and bases, Ka. In this lesson, we'll be focusing on weak acids and bases. We're going to be looking at Ka and pKa, and then we're going to end off by looking at some calculation questions. Make sure you check out the description below. I've added some helpful links, including access to lesson resources via Google Drive and information on how you can join our upcoming live sessions. So if we get started now, this is what we're going to be covering in more depth. This is what the spec says, and this is the part of the spec that we are going to be covering. Okay, so starting off by looking at weak acids. Now, weak acids partially dissociate in solution. You should know this from GCSE. And if we have a look at this equation, we've got HA reacting with H2O because we're putting it in aqueous solution. And then we're forming H3O plus and A minus. Okay, now this is basically simplified into this expression that we have over here, where HA in aqueous solution is dissociating into H plus and A minus. And the reason why is because H2O is large. Remember, H2O is a constant, so we don't really need to include it. Therefore, we would pretty much ignore it and turn this into a reversible reaction where HA in aqueous solution dissociates into H plus and A minus. Okay, so what's the Ka expression? Well, the Ka expression is literally just the normal equation that you would work out Kc with. Okay, so we've got Ka is going to be H plus concentration, A minus concentration, all over concentration of Ha. Okay, and that's the Ka expression that we have there. Make sure you learn that expression because we will need it when we are looking at some calculation questions. Okay, now the dissociation for a weak acid occurs in a 1-to-1 ratio. So remember, over here in this equation, where from Ha, we're dissociating it into H plus and A minus, and this is for a weak acid. We assume that the dissociation splits equally. So the concentration of hydrogen ions is the same as the concentration of A minus ions. As the amount of dissociation is small, remember, weak acids only partially dissociate in solution. Because the dissociation is small, we assume the initial concentration of the undissociated acid has also remained constant. Okay, and all this means is if we look at the new Ka expression, we're going to have Ka equals H plus squared over concentration of Ha. And the reason why this is the new expression is basically because of this fact. We've got H plus concentration is the same as the A minus concentration. Therefore, because both of them are the same, we can just simplify it. Instead of having H plus and then A minus, because we know both of them are the same, we can just literally combine them together and square them. And if we square root whatever answer that we get, we would get the individual concentrations, which would be the same for both H plus and A minus. And if we look at the second fact, because the dissociation is really small, the undissociated acid has remained constant. Therefore, we still have the concentration of the original acid at the bottom, Ha. Okay, because the amount of acid which has dissociated is relatively small. You need to learn this Ka expression as well because we're going to be using it when it comes to calculation questions. Okay, now expression for Ka. It's really simple, but normally in exam questions, they will normally start off with an easy 1 marker where you have to write down the Ka expression. They would give you an equation that you have to do it for, and that's what we're going to do here. So we've got CH3, CH2, COOH, which is propanoic acid, and we are literally dissociating that. We're forming a H plus and we're forming the A minus, which is this. However, when we're writing the Ka expression, we don't write A minus because we know what that A is. So our Ka expression is just going to be H plus, CH3, CH2, COO minus, all over CH3, CH2, COOH. Okay, and normally you would be given this in an exam as a starting 1 marker for the question, and that's what they're looking for there. Now it says write an equation for the dissociation of ethanoic acid and its Ka expression. Okay, this time it's a bit harder. So we've got ethanoic acid. If you're ever struggling with working out the formula, just draw it out. Ethanoic acid. So we know that there's going to be 1 carbon chain, and then we've got the COOOH. Yeah, and then we've got the methyl group, which is over here. So we've got CH3 COOH. That's ethanoic acid. Okay, so we've got CH3 COOH. Okay, and we've got our reversible reaction, and we're going to dissociate into H plus, because remember we will always form the H plus because it's a weak acid, and then we're going to add the A minus, and literally all we have to do is subtract the H plus, because we've split out the H plus. We're just going to be left with CH3 COO minus. That's the A minus. So the key with these equations, always remember that you're always going to form this H plus, okay, because it's a weak acid that's dissociating. So we're always gonna, whenever something dissociates, an acid dissociates, it's releasing hydrogen ions in solution, so we're always going to form the H plus. And if we form the H plus, we just need to subtract the H plus from the original acid, so we're left with COO, and because there's no H bonded to it, it has a spare bond that it can bond to, that's why it's minus. So that's the equation. Now we need to also write the Ka expression. So it's going to be same as before. Ka equals H plus CH3 COO minus all over concentration of CH3 COOH. Okay, and that's your Ka expression. Okay, now if you start off looking at calculations, so it says calculate the pH of a solution of 0.01 mole per dm cubed of ethanoic acid. Okay, and we're given the Ka, so we know that we need to be using the Ka expression somewhere, and because it's a weak acid, what you must know is that the concentration of H plus and A minus is going to be the same. So we're gonna write down Ka equals H plus A minus all over HA. Okay, and normally some mark schemes will give you the a mark for that, so make sure you just write it down in any case. We know that Ka is 1.7 times 10 to the negative 5, so we're gonna have 1.7 times 10 to the power of negative 5. And remember, the hydrogen ion concentration and the A minus concentration is the same. Okay, so we can literally simplify that to H plus squared. And that's over the concentration of acid. So remember, it says the concentration of acid is 0.01 mole per dm cubed of ethanoic acid. So we're going to be dividing by 0.01. If we rearrange this, we would get 1.7 times 10 to the power of negative 5 multiplied by 0.01, and that's going to be equal to H plus squared. Now, if we type this into our calculator, we have 1.7 times 10 to the power of negative 5 multiplied by 0.01. That's going to get us 1.7 times 10 to the power of negative 7, and that's the hydrogen ion concentration squared. And to get the hydrogen ion concentration, we would need to square root. Okay, so H plus concentration is equal to the square root of your answer. Therefore, the hydrogen ion concentration is equal to 4.123 multiplied by 10 to the power of negative 4. And it says calculate the pH, so we know we just need to negative log base 10 of our answer. Okay, and if we negative log base 10 of answer, we would get an answer of 3.38 to 2 decimal places. Remember, pH must always be quoted to 2 decimal places. Okay, and if you wanted steps over here, work out the Ka expression, look at the concentrations, substitute in your concentrations, and then negative log your hydrogen ion concentration that you have worked out. Okay, we have another question over here. It says calculate the concentration of propanoic acid with a pH of 3.52. So whenever we're given the pH, work out the hydrogen ion concentration. That's what we're going to do. So we're going to have 10 to the power of negative 3.52. That would work out the hydrogen concentration. You could keep your answer in exact form, but I'm just going to work it out. Okay, so you're going to have 3.019957172 times 10 to the power of negative 4. And this is your hydrogen ion concentration. Let's write down our Ka expression because we're given the value of Ka over there. So we know that Ka is equal to H plus A minus all over HA. We know that Ka is that, and we also know that because it's a weak acid, these two concentrations are going to be equal. So we can simplify this now. So we're going to have 1.35 times 10 to the power of negative 5, and that's going to be equal to this over here, which is still in my answer. So I'm going to answer, and remember that's going to be squared over HA. Okay, we need to calculate the concentration of that acid. So all we're going to do is we're going to rearrange. So we get that the concentration of acid, which is HA, is equal to our answer squared divided by 1.35 times 10 to the power of negative 5. Okay, now this is what you're going to be typing into the calculator. Okay, now remember the answer is just this over here, answer, just to make that a bit clear. Okay, so we're going to have answer squared over 1.35 times 10 to the power of negative 5, and that's going to give you an answer of 6.76 times 10 to the power of negative 3 mole per dm cubed for our concentration of acid. Okay, so all we've done that is we've worked backwards. We had the pH, so we worked out the hydrogen ion concentration. We wrote down our Ka expression, and we realized that because it's a weak acid, the H plus concentration is going to be equal to the A minus concentration. So we simplified that to Ka equals H plus squared over HA. We wanted to work our HA. We knew the hydrogen ion concentration, so we just rearranged and worked out the concentration of propanoic acid. Okay. And finally, one last thing that we're going to look at in this lesson is basically how we convert between pKa and Ka. Okay, and this is what you need to remember. pKa is equal to negative log base 10 of Ka. And Ka equals 10 to the power of negative pKa. It's just like pH and hydrogen ion concentration. So remember, pH was negative log base 10 of H plus concentration, and we saw that H plus concentration is equal to 10 to the power of negative pH. If you know this, it's really easy to learn that because pKa is equivalent to the pH. that's negative log base 10 of Ka, which is equivalent to the hydrogen ion concentration. Okay, and if we look at this question over here, it says calculate the pH of 0.1 mole per dm cubed of propanoic acid with a pKa of 4.87. Okay, so if we're given the pKa, always work out the Ka. So we know that Ka equals 10 to the power of negative pKa. We're given pKa to be 4.87. So we're going to work out Ka equals 10 to the power of negative 4.87. Okay, so 10 to the power of negative 4.87 is going to be equal to 1.34896 multiplied by 10 to the power of negative 5. That's our Ka. And now we know our Ka, and we know the concentration of propanoic acid. We can calculate the pH. Okay, so I'm just going to store this as A in my calculator. We know that Ka equals H plus A minus over HA. Okay, Ka is stored as A in my calculator. We've got H plus, which we need to work out, and that's going to be the same as A minus because we're dealing with a weak acid. It will always tell you in the question if it's a weak acid or not. So it's H plus squared over HA, which is just this, 0.1. Okay, so we're going to rearrange. We're going to get that H plus squared equals A multiplied by 0.1, which means that H plus squared is equal to 1.3489622883 multiplied by 10 to the power of negative 6. And then we can square root our answer to get the H plus concentration, which is equal to 1.1614 times 10 to the power of negative 3. And now we have our H plus concentration. We can negative log base 10 of our answer, and that's going to give us pH. And that's going to give us an answer of 2.935. And remember, pH should always be quoted to 2 decimal places. So that would get you an answer of 2.94. Okay, to 2 decimal places, and that's pH. Okay, I'm just going to highlight my answer just because there's a lot of working going on there. Okay, and that's basically pKa and Ka. Okay, so we've looked at weak acids, the expression for Ka. We've looked at some calculation questions, and we finished off by looking at pKa and Ka. In the next video, we're going to be looking at more difficult questions with weak acids and bases, because a lot of them come up in exams as 4 or 5 markers. Okay, and that's it for this video. If you have any questions, feel free to drop them in the comments below. Don't forget to check the description for any useful resources, and also to sign up for our live sessions. If you'd like to support us, you can buy us a coffee using the link in the description. Thanks so much for watching, and I hope to see you in the next video.